Today we're going to be looking at congruent triangles, or congruence or congruency. I don't know how they pronounce it at your school. I think congruence or congruency, either of those go. Okay, we're going to first be doing a bit of a recap on these angles. I call them fun angles. I call them fun angles. I don't know what they call them at your school, but we call them fun angles. And normally whenever we see fun angles is because somewhere they are parallel lines. So just like the same way, fun X. Okay, fun X. I like fun X. Okay, so every time, guys, you hear me say, same way when we're doing trigonometry, whenever I say, what is step number one? Everybody says, label, ma'am. Hello, Vukosi. Right. In this case, whenever you hear ma'am say parallel lines, whenever you hear ma'am say parallel lines, your go-to answer is always going to be fun, because of fun angles. We're going to be working with fun angles. Now, let's remind ourselves quickly what our fun angles actually are. Okay, remember, we need to make sure that we have parallel lines in order to use fun angles. Okay, in this first one over here, this is an F for corresponding. So that's an F there, an F for corresponding. F. Over here, I've got an N. You can see if I use my two parallel lines, that gives me an N over there. That's an N like that. This is called your alternate angles. Okay, and those two angles are equal to each other. These are equal, and these are equal. And then the last one, which is actually your co-interior angles, are not equal to each other. They form a U, but they're not equal to each other. Together, they add up to 180 degrees. Good, Ulani, you got this. All right, so we need to remember that. So I'm going to give you guys just a few minutes. I want you guys to answer. In these three, I want you guys to use the idea of your fun angles to find me all three angles of X. In number A, there's X. Over here, there's X in B, and there's X in C. All right, find me an answer for those, and then we'll get started. Right. All right, I'm seeing the emojis coming in, so I'm going to assume that we're all kind of sort of there, and these shouldn't be that difficult for us to do. Okay, but we always do need to remember, guys, that because we're doing geometry, we need certain things, right? In geometry, we always need a statement, and we need a reason. We always need these two things. Okay, we must have a statement, and we must have a reason. V, it's an online boot camp. It's an online boot camp, so you don't have to go anywhere, my darling. You will just be online. It'll just be a Saturday, and we'll be in exam mode. So yes, there will be food at the boot camp. It will just come from your house, V. It will come from your own fridge. That's where the food will come from. Okay. All right, let's start with this first one. I know if I look over here, x is going to equal to 59 degrees. Okay, and my reason here is because of alternate angles. I can see my n. There is my n or my z, however you call it, right? Alternate angles. And remember, if I use the reason alternate angles, I also have to give the parallel lines. So I know that the parallel line here is CF. So I'm going to go CF is parallel to GJ. I need to give the parallel lines in order to do that. All right. In question two is a multi-step kind of situation. So I need to find H first, and then we'll have to find X. So I know in order for me to find angle H, I'm going to say angle H plus angle I, or 55 degrees over here, is equal to 180 degrees. My reason there is because of co-interior angles. Okay, there is my U there, like that. That is my U. And my parallel lines are going to be AK. AK is parallel to BL. Right. So that tells me that angle H is then equal to 125 degrees. So I know, yes, reasons are always for marks. Correct, Abu. Right. So we know if this is 125 degrees, then X, therefore X is also equal to 125 degrees. Who can give me the reason why can ma'am say X is equal to 125? Not adjacent, that's it, Kulani, correct. They are vertically opposite angles, vert-op angles. Good. That's it, Sanele. All right, good, vert-op angles. Okay, if we go to this last one over here, I'm going to say angle X plus 41 degrees plus 60 degrees. All of that is equal to 180 degrees. And my reason there is co-interior angles. There I've got my U, there is my U. There. So all three of those together will give me my co-interior angles, and my parallel lines are going to be AC is parallel to DG. AC is parallel to DG, right? Therefore, X is equal to 89 degrees, 99, 89, 19, 79, 79. 79 degrees, yeah. 79 degrees. There we go. All right, cool, 79 degrees. Okay, cool. So that's just the beginning. Now we're quickly going to look at congruence or congruency. It doesn't matter how your teacher say it. We're first going to look at the rules behind this. Okay, let's look at the rules here. Yes, don't forget the degrees. Good. Okay, we're going to look at the rules that we have for congruence. Now, okay, let me explain, Princess. Okay, I'm quickly going to explain Princess's reason. Okay, so remember, Princess, in order for us to use things like co-interior angles, they need to be in between parallel lines. So there is my one parallel line over there, and there is my other parallel line over there. Only if I join them using this line in the middle, can I then use co-interior angles. So I need to use all of them. All of them. Now, if I were to do this, if I were to turn there and turn there, these two lines are no longer parallel. Do you see how those lines aren't parallel? So I can't use those two. I can't use those two. I need to use the parallel lines that have been given. And the thing that tells me that they're parallel lines is these arrows. The arrow over there and the arrow over there tell me that they're parallel. So I need to use that one and that one. Those two give me the U. Does that make sense, Princess? Nitifatso, what's up, my darling?
Ma'am, can you hear me?
Yes, absolutely. Go for it.
I was asking, right, for the triangle. I used interior angles of a triangle. I added 60 plus 8 and then made them equal to 180.
Oh, okay. So let me guess. How did you find out? Where did you get this angle?
Ma'am, I made them what you call it, alternate angles.
Correct, absolutely. So there's nothing wrong with that. 100%. Your maths is 100% sound. As long as you started by first finding angle E and telling us that that angle was 41 degrees. So you had to do just a little bit more work. Okay, so you first had to say angle E equals 41 degrees, and then you need to tell us that it's because of alternate angles, because AC is parallel to DG, and then only after that can you then say, therefore, x plus 60 plus 41 is equal to 180 degrees because of interior angles of a triangle. You're more than welcome to do that. It just means you go one extra step. Okay, is that okay? Okay, your answer is not wrong. It's just, unfortunately, Nitifatsa, we're not going to give you an extra mark for doing extra work. You're just going to get the same amount of marks if you're okay with that. Okay. All right, my darling, you're not wrong at all. That is perfectly sound mathematics, 100%. Okay, let's talk about congruence, guys. Okay, let's talk about congruence. Now, I want you guys to note that there are really only 5 rules for congruence, but let's talk about the word congruent. What does congruent actually mean? When we say that 2 shapes are congruent, what do we actually mean about these 2 triangles or these 2 shapes? Correct. Yes, Tabitha, I will take equal, but let's be a little bit more specific. Oh, Vugosi, I'm not going to accept similar because we're going to be learning about similar triangles on Wednesday. And Buhle, you've hit the nail on the head. Congruent shapes need to be exactly the same. Exactly the same. And Omi, you're correct as well. Oh, Narisha giving out sweets, just like, love it, good. The word that I like to use is that they need to be, Narisha, please give V a sweet as well, because V's answer is the answer I was looking for. They need to look identical. They must be identical. They must have the same sides. They must have the same angles. The angles must be next to the same side. The sides must be next to the same angle. Everything about them must be curated beautifully and identically. V, I love it. Excellent work. Good. They must be identical. So we're going to look a little bit in more detail at these reasons for congruence. Right, for these reasons for congruence. And we're going to have to understand exactly what it is that we're looking at here. Now, if we look at this first one, side, side, side is a pretty easy reason for congruence. We can tell if this side and that side match, and that side and that side match, and that side and that side match, then our reason is side, side, side. But the other reasons are curated in a way that is very, very particular to what we're doing here. I would advise you to take a screenshot of this if you can, or do some rough drawings, but I need you guys to focus very carefully as we go. Now, if we look at the reason, side, angle, side, do we note that the angle is in between the 2 sides? Do we see that? The angle is in between the 2 sides. So look at the way that your 2 triangles have been drawn. There's a side and then an angle and then a side. So that tells me that I need 2 sides with an angle in between. Same as over here. I need 2 sides with an angle in between. And in the other triangle, I also need 2 sides with an angle in between. All right. So we need to be very, very careful. In order for us to use side, angle, side, the 2 sides must correspond and they must have the same angle in between. Okay, good. Now let's go to angle, side, angle. I think you all know where I'm going with this. Yes, there must be 2 angles with a corresponding side in between. You see that? I've got an angle, and corresponding side, angle, angle, corresponding side. So we need to make sure that they are exactly curated to suit each other. Right, look at this one over here. This one gets a little bit tricky, right? Because I've got angle, angle, side. Now with angle, angle, side, I want you guys to note here that I need the angle, and then the side must be next to the same angle. Both of the sides must be next to the same angle. So if I've got an angle and then an angle, and my side is to the right-hand side of my angle, then in this other triangle, I must have an angle and an angle, and the side must also be to the right-hand side of my angle. So if in this triangle, I had angle, angle, side, but on this side I had angle, angle, and side over here, are those two still congruent? Nope, they wouldn't, because my side is over here. So they wouldn't be congruent. Okay, and then I see Narisha say, for the fourth pick, can you say side, angle, angle? No, we cannot. We cannot say side, angle, angle. We are only allowed to use the ones that we've been given over here. Okay. All right. We don't really accept side, angle, angle. It must be angle, angle, side. Okay. Even if you write it side, angle, angle, when you are proving it, you must write angle, angle, side. Okay. Then the last one that we have over here, the RHS, tells me that I need a right angle, I need a hypotenuse, and I need a corresponding side. But then again, guys, have a look. Have a look. I've got my right angle, and then I've got my hypotenuse. I've got my right angle, and I've got my hypotenuse. Look at this. My side sits to the left of my right angle. And in this other triangle, my side also sits to the left of my right angle. Okay, so they need to both be on the same side. The only time it may not be true is if they've taken my two triangles and they've drawn them like this. If they've drawn them like that. Okay, but then in that case, they share a side. So it counts because they both share a corresponding side. All right, it's very important that we understand that. Oh, Narisha, it's not right-hand side. It stands for right angle. Right angle. The H stands for hypotenuse. So we need a hypotenuse. Okay, it stands for right angle, hypotenuse, and side. So not right-hand side. Okay, like we do when we're proving in trigonometry. This one stands for right angle, hypotenuse, side. Okay, so, and then I want you guys to take a note of the fact that side angle does not exist, but I will tell you guys why. I'm going to show you guys why as we go. You'll see one of the examples that we're going to do. We'll discuss why it doesn't count. All right, let's do this exercise. This next exercise we're going to do together as a class. Okay, we're going to do this. Okay, we're going to decide together as a class. Are these two, we're going to start with number 1 all the way to number 6. Are the two triangles congruent? We're going to start by saying yes or no. If we say yes, we need to give a reason. So we need a side, angle, side, or a side, 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 or an angle, angle, side. And if we say no, then we need to be able to know why we are saying no. Okay, let's start with number 1 together as a class. All right. Is triangle ABC congruent to triangle DEF? Vukosi says yes. Everybody says yes. Pumzile also says yes. Let's think of the reason why. What is our reason specifically? I agree with you guys. It is yes. Okay. Furufero says side, angle, side. And I agree. Right. The reason is going to be side, angle, side. Let's see why. I have a side, I have a side, and I have an angle in between. My angle is called W. And on this side, I also have, on my left-hand side, there's 1. On the right-hand side, there's 2 lines, and in between, there's an angle named W. So correct, it is side, angle, side. Beautiful work. Good. Let's talk about, oh, Theo, I'm loving how you're even saying given, because, because it's correct that it's been given to us. Let's talk about number 2. Is number 2 congruent? Yes or no? Okay, V says yes, and V even gives us a reason. V says, what's our reason? Correct, fellow, and you and V are 100% on point. It is indeed side, side, side. I want us to note now that that side and that side correspond, that side and that side correspond. Where is the third side? Where's the third side? Yes, Theo, beautiful. They have a common side. So we know that AC, this is a common side. Beautiful work, guys. Good, it's a common side. Excellent. And I feel like this lesson is going to go fast because you guys seem like you're awake, guys. You're clocking the stuff. All right, let's talk about number 3. Is number 3 congruent? Yes or no? Oh, Omi jumped right in there. Correct. Omi says yes. And the reason everybody's giving is right angle, hypotenuse, side. I want to double check. I'm going to go double check. Right, I've got a right angle. I've got a right angle. There's my hypotenuse with 2 lines. Good. There's my hypotenuse with 2 lines. Excellent. Now I just need to make sure that my other side is sitting on the correct side of my right angle. Now, if I look at this right angle over here, my side is to the left of the right angle. And on this side as well, there's my right angle and my side is to the left of my right angle triangle or of my right angle. So this is indeed right angle hypotenuse side. Excellent. Let's talk about number 4. Congruent or no? Narisha says no. Gift also says no. What do the rest of us say? Abu says nah. Nah. Okay, Theo, check again. Okay, everybody's saying no, and I agree it is no, because look, guys, even if we had angle, right, side. Look at this one. I would need angle, side must be next to M, or I need angle, side must be next to N. So they don't count because they don't have the same side, like they don't have the side next to the correct angle, right? So no, that one is not equal. Let's go to the last one over here. Are these two, number 5, congruent or no? Kriani says yes, RHS, Philfellow says no. Bukosi says yes. Okay, Omi says yes. Gift says no. Theo, I'm getting very conflicting answers, guys. I'm getting conflicting answers. Oh. Okay. Ooh, I'm getting many no's, many yeses. Okay, let's go and have a look. Let's go. Omi's like, no, actually, no, it's not. All right, let's look. There is my right angle and my hypotenuse. There is my right angle and my hypotenuse. However, in this right angle, in this triangle, my right angle is to the left, or my side is to the left of my triangle, but in this one, my side is to the right of my triangle. So, is it? No, it's not. No, it's not. It's not. Okay, they're not on the correct side. They're not on the correct side. Okay, let's go to number 6. What do we say of number 6, guys? Number 6, Kriani says no, no. Why not? Why not? Okay, no, because we cannot have side angle. Side angle is not a thing, right? Let's talk about why side angle is not a thing. Let me do this. Let's say, for instance, guys, I draw a line, right? If I draw a line, but they're not twinning. Okay, so if I draw a line, let's say, for instance, this line is 5 centimeters long, right? I'm going to duplicate this exact same line, right? Copy, and I'm going to paste it over here, right? I've got the exact same line, also 5 centimeters long. No difference there, right? Then I'm going to go and I'm going to draw another line from there to there, right? And I'm going to make this line 6 centimeters, right? Now, I know that these 2 lines make a particular angle over there. We don't know what that angle is. Let's just call it theta. No, Pumizile, not really. It was just for the exercise. Okay, it was just for the exercise. Now, I'm going to copy this exact same line, copy, and I'm going to paste it over here. It's still a 6 centimeter line, right? Because it's exactly the same line as that one. But I'm going to then do this. It's still 6 centimeters, right? Are my 2 angles the same? Can I name this angle theta? Nope, I can't do that. I can't do that. Not at all. I can't do it. That is why we cannot use side angle. as a reason. Side-side angle doesn't exist as a reason, because if this side is 5 centimeters and this side is 6 centimeters, this side is 5, this side is 6, that doesn't mean that the angle that we get from them is the same. We won't even get the same angle over there. We wouldn't get the same angle over there. So we can't say side, side, that angle won't be the same and that angle won't be the same. Okay, and that is why we cannot use side-side angle as a reason. All right, everyone with me there, give me a thumbs up. Do we understand why side-side angle does not work? Correct. You could even make it an acute angle. It wouldn't work. All right, it wouldn't work. So we cannot use that as a reason. All right, peeps, let's jump into some proofs. Okay, let's go through some things that we need to know before we do these proofs. Okay, but the crux of it is that we need to know a couple of things before we get started. All right, whenever we're looking at a triangle or any shape, when we see lines across, right, if we see lines across, if we see that and that, what do the lines mean? What do lines actually mean? Lines tell us that the two things are equal. Correct. They tell us that they are equal. Good. They tell us that they are equal. If I see arrows, what do arrows mean? What do arrows mean, guys? Good. Oh, me. Absolutely. It means parallel. Arrows mean parallel. And whenever we see parallel lines, what must we think, guys? Whenever we see parallel lines, we need to think fun. Good. We need to remember our fun angles. All right. Parallel lines, fun angles, and it's going to come up. Okay, so let's talk about proofs a little bit, because you're going to have to prove a lot, especially when we start getting to quadrilaterals. Quadrilaterals require us to prove, but there's a particular order in which we need to do things. And before we get there, Narisha, I see what you're saying and you're completely correct. I need us to take it just a step at a time. I want us to note, guys, the order in which the triangles that we're trying to prove have been given to us. Okay, watch what they're saying here. They're saying in quadrilateral ABCD, AB is equal to BC, AD is equal to CD. This is nice given information. We're going to use it in just a little bit. What I want us to focus on a little bit is how they've written the triangles. They're saying, prove that triangle ABD. Do you notice the order in which they move? They start at A, they go to B, and then they go to D, and then close up the triangle, right? I want us to note that when they start at A and move over B, do you see how they go past one line? They go past the side with one line. That means before we even see the second triangle, where are we going to start in the second triangle at? Where would we start in the second triangle? Okay, if we started here at A and we moved past one line, good. We're going to have to start at C and move past one line and then through the middle and then past the two lines, just like we did in the other triangle. Good. So we need to map it out in the correct order. And I'm being very OCD and pedantic about this because when we start looking at quadrilateral proofs, they are not going to give you these triangles. You're going to have to map them out yourself. So it's very important that we do it in the correct order, guys. Okay, it's important that we do it in the correct order. So that means that if I'm going to prove, I need to make sure that I'm writing the triangles in the correct order. Now, watch how they start the proof. They start by saying proof. We're always going to start by going proof. In triangle ABD and triangle CBD. Okay, now because these are triangles and we're proving congruence, we need 3 reasons. That's why they've written here 1, 2, 3. We always need 3 reasons. Let's start with the first one. We're going to say AB is equal to what? AB is a side. AB is equal to What? Which side? BC or CB? Right, good. BC or CB. My reason is that it's been given to me. Lovely information given to me. Remember, guys, it's geometry. We need a statement and we need a reason. We need both. Good. Then we're going to go to AD. AD is equal to what? Ah, thank you, V, for reminding us that this is a side. Good. AD is equal to CD, and that is also given. No, not in this case. Not in this case, Fulani. Not in this particular case, because they're opposite sides of what? We don't know. All we know is that it's a quadrilateral. It doesn't tell us what kind, so we cannot say that. All right. They didn't say the kite ABCD, they just said the quadrilateral ABCD. It could be any regular quadrilateral. They haven't told us all the information. So no, we cannot say that. Okay. Then we're going to go to the last reason here. BD is what? BD comes out in both. So BD is common. Right. And that is also a side. That is also a side. Then we can say, therefore, triangle ABD, and I want you guys to note the symbol for congruence. That is the symbol, 3 lines. 1, 2, 3 is congruent to triangle CBD, and our reason for congruence is side, 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 south, southern, southland. Okay. All right. Okay, now it's your turn. Let's do number 1. Okay, start with number 1, peeps. I'm going to take a screenshot of it because I want us to do it together, actually. Okay, I want us to note what we need to do in this particular question. All right, let's start. Here it is. Okay. So they want us to prove that triangle ABO is congruent to triangle DCO. So when I start, I'm going to start by saying proof. Now, let's make sure that they've mapped out their triangles properly. We're going to start. We're going to go in triangle ABO. Let's see how they've gone. They've started at A, and look how they've gone past the side and they've gone past the line and the arrow to B, and then down the middle, and then that way. So in the next triangle, we also need to start there, and we need to move past the line and the arrow, and then to the middle, and then down. So in triangle ABO and triangle DCO, right? Narisha says, can we say opposite angles? What do you mean by opposite angles, Narisha? I'm not sure what you mean by opposite angles, my darling. I need you to elaborate for me. I need 3 reasons. Reason 1, reason 2, and reason 3. Only then can I say therefore. Okay. Okay, where do we start? Who's got a place for us to start? Okay, before we get to the alternate, let's start with the most obvious. What does that tell us? What does this tell us? AB is what? AB is not parallel. They're not parallel. Good, Zikatelo. AB is equal to CD. Remember we said lines mean equal. Good. And it is given. That is our reason. It is given. Right. That is a side. And Narisha, my darling, you are spot on. It went past me, but you're not wrong. Okay. I just want to make sure I find it. I find it excellent. Narisha says that O1 is equal to O2, and she's spot on. Yes, O1 is equal to O2. And the reason for that is that we've got vertically opposite angles. Beautiful. That's an angle. Right. And then the last one, you can give yourself a sweet, Narisha. You deserve one. Okay. And then the last one, which one can we say? Okay, remember that the parallel lines don't tell us very much. That's it. Correct, Theo. That's correct, Theo. Angle A, the angle A is equal to angle D. And what is our reason, Gift and Theo? Good. We have to say alternate angles. And we also need to name the parallel lines. We need to say that AB is parallel to CD. Okay, and there's our three reasons. Okay, from there, we can then say, therefore, triangle ABO is congruent to triangle DCO. Now, side angle is not a reason. Side angle is not a reason, but let's go and map it out. Okay, we've got angle O1, we've got angle A, and we've got side AB. Over here, we've got angle O2, we've got angle D, and we've got side CD. That is an angle, then an angle, then a side. Do we see that? Angle, angle, side. Same way, my angle A needs to be next to my side, and my angle must be on the left of my side, and my angle D must be on the left of my side. So my reason for congruence here is angle, angle, side. Okay. We need to make sure that we're using the reasons properly. Yes, absolutely, you can. You can, Fulufelo. You could also have said that angle B is equal to angle C for the exact same reason. Okay. Narisha, angle is for similarity. We're not doing similarity, we're doing congruence. Similarity is on Wednesday. Okay. All right, excellent. I want everybody to try number 2. There is number 2. I want you guys to go ahead. I want you guys to note in number 2, are any of those sides, do they give us any of these? No, they don't. So we can't now just decide that sides are equal to each other without actually knowing it. All right, curate your answer properly. Remember to start properly, guys. Start by saying proof. Proof. In triangle, do your due diligence. Map out your triangles. Make sure you're doing it correctly. All right. Yes, Gift. Fun must apply because we've got right angles. Sorry, we've got parallel lines. We've got parallel lines, sorry. How are we doing, peeps? Okay, Fulani Princess and Narisha are done. We'll give everybody else just 30 seconds. Well, as I say it, everybody else comes to the party. All right. All right, let's get into it. Let's get into it. Okay, so we're going to start with proof in triangle. Now, look at the way that they've moved. They've gone from A, past the side with only one arrow, and then to C. So in triangle, ADC, and in triangle, which means when we start the next triangle, we also need to go over the side with just one arrow. So we need to start at C, go up past B, and over the one with two sides. So that must be in triangle ADC and triangle CBA. Very important that we do it in the right order, guys. Don't forget. Okay, I need 3 reasons. 1, 2, 3. Okay, I see parallel lines everywhere. So I'm going to use my fun angles, right? I'm going to start by using my N there, my alternate angles. I'm going to say angle A1 is equal to angle C2. A1 is equal to C2. And my reason there is alternate angles. And I need to make sure I'm using the right parallel lines. This case, I've used AB is parallel to CD. Right, that's my first one. Then I'm going to go to my other N for fun angles, that one. And then I know that angle A2 is equal to angle C1. Right, angle A2 is equal to angle C1. And again, I've got alternate angles but this time it's because AD is parallel to BC. Remember, guys, you lose the mark if you do not write which parallel lines you used. AC is parallel to BC. AD is parallel to BC. Good. My last one is going to be that AC is common. Good. AC is common. Now, I know that if I look at the way that this thing is written, I've got angle, angle. Yes, correct, Omi. If your reasoning is wrong, then the whole thing is wrong. Okay, unfortunately. So we've got to get used to that. Okay. Therefore, triangle ADC is, look, now I've written an A instead of triangle. Therefore, triangle ACD is congruent to triangle CBA. And I know it's easy for us to just look at this thing and say it's angle, angle, side. No, it's not. Let's go back and have a look, guys. I've got an angle, I've got an angle, and I've got a side in the middle. And I've got an angle, and I've got an angle, and I've got a side in the middle, correct? So my reason should be angle, side, angle. Okay, I see Fulani say, ma'am, can you write AC is equal to AC? Then the reason will be common because that's how we write it at school. That's fine. That's perfectly fine. To be honest, it sounds redundant to me because like it's the same as saying 2 is equal to 2. What are you trying to tell me? That AC is equal to AC because AC is equal to AC? Yeah? Yeah? Okay, but it's fine. Both of them are correct. If that's how you write it at school, that's how I want you to write it. Okay. Write it that way at school. Is everybody okay with this idea, guys? Are we all good? We've got 2 more to go. How are we feeling, guys? We good? Excellent. There's your next challenge, number 3. Let's do numbers 3 and 4. I'll give you a chance to do both. Do numbers 3 and 4. Pop your favorite emoji in the chat when you're ready. Okay. Remember to start properly, guys. Proof in triangle. In triangle this and in triangle that. Proof in triangle this and triangle that. And I'm just going to quickly run. Okay, no, I'll go after class. It's fine. Not a problem at all, Sanele. For just 3 seconds. You've got exactly 3 seconds. 1, 2, 3. I'll give you 2 more. 4, 5. Okay. And if you haven't screenshotted, we're going to have to come back at the end of the lesson. Okay. Good. Excellent. All right. Keep going, guys. You got this. All right, I'm seeing quite a few people done. I'm going to give everyone else 1 more minute and then we'll get started. Okay, peeps, that's time. Let's have a look at both of these. Okay, if you're not done, don't stress. We're going to chat quickly. Okay, so proof in triangle. Now they want me to start at MNP. So I'm going to map out MNP. M right past my arrow and my line down the middle. And then, okay, so if I start the next one, I'm going to have to start at P. Oh, I'm lying at O, and then P, because if I went that way, I'd have to go up first. So I need to start at O and go past the line and the arrow and then up. Okay, so that's going to be in triangle MNP and triangle OPN. 3 reasons. 1, 2, 3. Okay, my first reason, I'm going to use MN is equal to OP. Nice for them to give it to me. Lovely, given. That's a side. And then I'm going to use my parallel lines. N1 is going to equal to P1. Angle N1 is equal to angle P1. That is because of alternate angles. My parallel lines are going to be MN is parallel to OP. And for the last part, NP is common. Okay, that's an angle and that's a side, and lucky for us, therefore triangle MNP is congruent to triangle OPN. My reason here, as it's been written, side, angle, side, side, angle, side. Okay, side, angle, side. There we go. That's our reason there. Okay, lovely. Let's go to the last one. Hey, over here, again, proof in triangle. I'm going to start at A, B, M. I can see they go from there, past the one with nothing, and then past the one with 2. So triangle A, B, M, and triangle. Now, they went past from A, past nothing, and then 2 of them. So I can't decide to go from C down and then past 1. I need to follow their movement. So from D, past nothing, and then past 2. So it should be DCM. In triangle DCM. Okay, 3 reasons. 1, 2, 3. I'm going to say that AM is equal to MD. That's a side, and it's been given. And then I'm going to say BM is equal to MC. That's another side, and it's also been given. And my last thing is going to be that angle M1 is equal to angle M2. And that is because of vertically opposite angles. And that's an angle. However, if I map it out properly, that's it, Abu. Perfect. Therefore, triangle ABM is congruent to triangle DCM. If I go and I look at my triangles, there is a side and an angle in between, a side and an angle in between. That is side, angle, side. Okay, tell me, how did we do? Did we get both right? Did you get one right? How did we do it? Fulufelo, for which question? For which question? Can I say angle B is equal to angle C? No, ma'am, we can't. We don't have enough information for that. Okay, we cannot say that B is equal to C. Nowhere does it indicate that that is true. All right, so we can't do that. Okay, unfortunately not. But well done to those of you who made it. Ooh, Fulufelo like number 4. No, my darling. No, we can't do that. Well done to you guys. All right, that's it for today's lesson.